What do we really know about the world we inhabit when so much of it has been learned from a distance? For most of human history, the night sky looked calm. The planets moved with a patient certainty. The stars held their positions like pins in velvet. From the ground, the solar system seemed orderly, almost finished, as if the great work of creation had already been understood and only needed better lenses, cleaner mathematics, and a little more time. But distance can be a kind of deception. The farther something is, the easier it becomes to mistake outlines for truth. A blur becomes a boundary. A flicker becomes a fact. And so, for centuries, we built a picture of the outer solar system from scattered light and careful inference, believing that what we could not touch might still be known with confidence. Then, in the 20th century, we began to send machines outward, small emissaries of metal, code, and human longing. They crossed the quiet gulf beyond Earth, carrying our questions into the dark. What they found was not a tidy extension of what we already believed. It was stranger than that, far richer, far less settled. They found worlds that should have been silent, yet were alive with motion. They found hidden structures, impossible storms, buried oceans, and distant frontiers where even the definitions we trusted began to fray. Again and again, the lesson was the same. The universe was under no obligation to match the version we had imagined from afar. This is the story of those revelations, not simply a story about spacecraft or planets, but about perspective itself, about how often truth waits beyond the edge of certainty, and about a species willing to launch pieces of itself into the cold, not because it expects comfort there, but because wonder has always asked more of us than safety ever could. Perhaps that is the deepest discovery of all, that every journey outward is also a journey into humility. What if the first great discovery of deep space was not what we found, but what was missing? In the early 1970s, the asteroid belt still lived in the public imagination as a place of danger. It was pictured as a crowded frontier between Mars and Jupiter, a shattered graveyard of stone where any spacecraft might be torn apart before it ever reached the giant planets. From Earth, that fear made a certain kind of sense. Through telescopes and mathematical models, the region seemed dense, chaotic, almost impassable. So when Pioneer 10 began its journey outward, it carried more than instruments. It carried a question shaped by human uncertainty. Could anything safely cross that wilderness? Or had we mistaken a narrow opening in the sky for a field of permanent threat? Then came the quiet answer. As Pioneer moved into the belt, the catastrophe many had imagined never arrived. No storm of rock, no metallic thunder, no desperate evasions. The probe passed through mostly emptiness, finding that the asteroids were separated by enormous distances, with more silence between them than stone. What had looked from far away like congestion was in truth vast open space. It was a humbling correction. Perspective had turned distance into illusion. The belt was real, but our way of seeing it had compressed that reality into something harsher and more crowded than it was. In one stroke, the solar system became less like a barricade and more like a passage. That crossing mattered far beyond one successful mission. It opened the road for everything that followed: the flybys of Jupiter and Saturn, the voyages to Uranus and Neptune, the patient expansion of human knowledge into regions once thought unreachable. A doorway had not been broken through. It had simply been recognized for what it was. And perhaps that is how discovery often begins. Not with the dramatic arrival of something new, but with the fading of an old fear. Sometimes the universe does not confront us with monsters. Sometimes it asks whether we are brave enough to let go of the mistaken shapes our own distance has drawn. How can a planet be studied for centuries and still keep something enormous hidden in plain sight? Jupiter had long seemed familiar. It was the giant of the old astronomy books, the striped monarch of the outer sky, watched by Galileo, mapped by generations of observers, and photographed so often that it felt almost known by heart. Its storms, its moons, its bands of color, these had become part of the visual language of the solar system. If any distant world appeared to have surrendered its major secrets, it was this one. And yet, in 1979, Voyager 1 revealed a detail no one had truly seen before. There, around Jupiter, was a ring system. Not bright and theatrical like Saturn's, but delicate, dusty, almost ghost-like. It had escaped detection, not because it was small, but because it was subtle. The ring was thin, dark, and nearly invisible unless sunlight struck it from exactly the right angle. For centuries, humanity had been looking straight at Jupiter and still missing what circled it. That discovery carried a quiet kind of shock. It reminded scientists that visibility is not the same thing as understanding. Even the most observed objects can conceal entire structures when our vantage point is wrong. Jupiter's rings had not suddenly appeared. They had been there all along, suspended in the dark, waiting for a shift in perspective. What made the moment even more beautiful was its modesty. These were not rings meant to dazzle. They were made of fine dust, likely lifted from small inner moons by constant impacts, forming a faint halo around the largest planet in the solar system. A fragile architecture around a colossal world, something almost weightless encircling something immense. And maybe that is part of the lesson the outer planets keep offering us. Reality does not always announce itself with brightness. Sometimes the truth is thin as dust, easy to overlook, visible only when we stop staring straight on and learn to see from the side. What else, then, remains hidden not by distance alone, but by the angle of our attention? What if the most restless place in the solar system was not a planet at all, but a moon? Before Voyager reached Jupiter, moons were often imagined as aftermaths, cold remnants, secondary bodies shaped long ago and left to drift in geological stillness. They reflected light, traced elegant orbits, and seemed to belong to the category of things already finished. If change was happening anywhere dramatic, we expected it to happen on planets. Then the cameras turned toward Io. Its surface did not look ancient and settled. It looked wounded, remade, alive with upheaval. Voyager's images showed towering plumes rising above the horizon, volcanic eruptions on a scale no one had ever witnessed beyond Earth. Lava spread across plains tinted yellow, orange, black, and red by sulfur and heat. The moon was not preserving an old history, it was writing one in real time. The source of that violence was invisible but profound. Io was being kneaded from within by gravity itself. Pulled by Jupiter, tugged by neighboring moons, its interior flexed again and again, generating immense tidal heat. The result was a world in constant convulsion, where the ground could not fully rest because space itself would not leave it alone. There was something almost intimate in that revelation. We tend to imagine the cosmos as distant, mechanical, detached. But Io suggested another truth, that worlds can be shaped by relationships, by forces exerted across space, by the pressure of being held too tightly within another body's reach. Its volcanoes were not just eruptions, they were evidence of connection, of tension turned into fire. And so a moon once expected to be silent became a symbol of hidden energy, a place where stillness had been an illusion, and where the deepest changes were driven by forces that could not be seen from the surface. Perhaps that resonates because human lives work that way too. What erupts in view is often only the final sign of pressures long at work beneath. Io reminds us that even in the cold outer reaches, nothing exists entirely alone. And sometimes the most dramatic transformations are born not from isolation, but from the invisible pull of what surrounds us. What if one of the most promising places to search for life lies beneath a shell of ice, far beyond the warmth of the sun? Europa does not announce itself with grandeur. From a distance, it appears pale and quiet, a smooth moon traced with dark lines, as though someone had pressed a cracked piece of porcelain into the black. But that stillness is deceptive. The surface tells a subtler story, one written not in mountains or fire, but in fractures, scars, and the quiet evidence of renewal. When spacecraft first sent back close images, scientists saw something unexpected. Europa had very few impact craters. For a world exposed to the violence of space, that absence mattered. It suggested a young surface, one that had not merely endured time, but had somehow been refreshed by it. The long streaks crossing the ice looked less like decoration and more like evidence of movement, places where the shell had split, shifted, and perhaps opened briefly before sealing again. That led to a possibility both elegant and profound. Beneath the frozen crust, there might be an ocean. It was a daring idea at first, almost too beautiful to trust. But over time, the clues deepened. Measurements pointed toward a salty, electrically conductive sea hidden under miles of ice. And if that ocean exists, it may contain more water than all the oceans on Earth combined. Not a relic of the past, but a living environment in the present, held liquid by tidal forces as Jupiter's gravity flexes the moon from within. The real power of Europa is not just that it may hold water. It is that its dark ocean could rest against rock, chemistry, and internal heat, the kind of meeting place where complexity begins. On Earth, life did not ask permission from sunlight alone. It also emerged in pressure, in minerals, in warmth rising from below. Europa invites us to imagine that biology may be less fragile and less lonely than we once believed. And that changes the emotional map of the universe. The search for life is no longer only a search for places that resemble home. It becomes a search for hidden habitability, for worlds that seem sealed and silent from the outside but carry possibility underneath. Europa reminds us that the most important things are not always visible on the surface. Sometimes an entire ocean waits below the ice, asking whether we have the patience to believe in what we cannot yet see. Can a moon with a shrouded face teach us something about memory itself? Titan arrives first as an impression, not a landscape. It is wrapped in haze, a golden veil so dense that, for a long time, it denied the simple comfort of a clear view. Through telescopes and even in early spacecraft images, Saturn's largest moon seemed to guard itself behind atmosphere. It was there, unmistakably real, yet withheld. A world present in outline, absent in detail. That obscurity made Titan strangely compelling. Here was a moon with weather, with layers of air, with a chemistry rich in carbon compounds. It was the only moon in the solar system known to possess a thick atmosphere, and that alone set it apart. But mystery deepened as instruments began to probe beneath the haze. Titan was not just another icy satellite. It was a place where nitrogen filled the sky, where methane behaved in ways eerily reminiscent of water on Earth, and where the surface participated in cycles of evaporation, clouds, and rain. Not Earth-like in the easy sense, Earth-like in structure, but translated into a colder language. Later missions would reveal lakes and seas of liquid methane and ethane, channels carved by flowing fluids, and plains shaped by processes both alien and familiar. But even before the details were complete, Titan had already done something important. It expanded the idea of what a world could be. It suggested that nature repeats patterns without copying outcomes. Rivers may exist without water. Rain may fall in a place colder than imagination once allowed. A shoreline can be real even when everything about it is chemically strange. There is something moving in that. Titan tells us that resemblance is not identity. We often search the universe hoping to find another Earth, another version of the story we already know how to tell. But perhaps the cosmos is more inventive than that. Perhaps it prefers echoes to replicas, variations to duplicates, atmospheres that feel like memories of home while remaining entirely their own. And maybe that is why Titan lingers in the mind. It is a world of partial revelation, where the hidden is not empty, but waiting. A reminder that understanding does not always begin with clarity. Sometimes it begins in the haze with the patience to keep looking until a new kind of familiar slowly emerges from the mist. What if a world could be both dazzling and fragile, built from countless pieces that seem eternal, only because we see them from far away? Saturn had always occupied a special place in the human imagination. Even through modest telescopes, its rings gave it an elegance no other planet could match. It looked designed rather than formed, like a symbol placed in the sky to reassure us that beauty and order were possible on a cosmic scale. For generations, those rings seemed almost solid in their perfection, as if they were permanent architecture. Up close, that illusion dissolved into something even more extraordinary. When spacecraft studied Saturn in greater detail, the rings were revealed not as smooth bands, but as immense collections of particles, ice, dust, and rock, each piece following gravity's choreography. They were structured, restless, and full of variation. There were gaps carved by moons, waves rippling through the bands, and subtle divisions shaped by resonance and motion. What looked serene from Earth turned out to be alive with collision, influence, and change. It was a revelation about scale as much as substance. Saturn's rings are vast beyond intuition, yet astonishingly thin in proportion to their width. A structure that appears monumental is, in some places, delicate as a breath. Their brilliance comes largely from water ice catching sunlight, but their stability is not guaranteed. These are not timeless ornaments. They are part of a system in motion, continually shaped by forces that build and erode at once. That tension gives Saturn a different kind of beauty. Not the beauty of permanence, but the beauty of arrangement. A reminder that splendor can emerge from vulnerability, and that order does not require stillness. The rings endure not because they are fixed, but because they are constantly being rebalanced by gravity, impact, and time. There is a human echo in that image. We also tend to mistake what looks composed for something unchanging. Yet many of the things we call stable, families, memories, civilizations, even identities, are really held together by ongoing motion, quiet negotiation, invisible influence. Saturn's rings invite a gentler understanding that what appears whole may actually be made of countless separate fragments, held in temporary harmony. And perhaps that does not make the scene less meaningful. Perhaps it makes it more so. Because anything that remains beautiful while being this delicate is not diminished by its fragility. It is defined by it. What happens to a world when something knocks it so far off balance that even its seasons no longer resemble anyone else's? Uranus is often introduced as the quiet one, a blue-green planet so distant and subdued that it can seem almost abstract. No great bands like Jupiter, no radiant rings like Saturn, at least not at first glance. Just a cold sphere turning slowly in the outer dark. But when Voyager 2 arrived in 1986, that apparent calm gave way to one of the strangest portraits in planetary science. Uranus does not spin like the other planets. It rolls. Its axis is tilted by about 98 degrees, so extreme that the planet seems to lie on its side as it circles the sun. The result is not merely an unusual season, but an almost unimaginable rhythm of light and darkness. One pole can face the sun for decades, while the other remains in a winter so long it outlasts entire chapters of human life. Then, slowly, the pattern reverses. Voyager revealed that the oddness goes deeper still. The magnetic field is wildly misaligned with the planet's rotation, tilted and offset as if the machinery inside Uranus had been rearranged long ago and never settled back into place. Even the moons and rings appear to participate in this altered geometry, orbiting a world whose very orientation feels like the aftermath of some forgotten upheaval. Scientists have long suspected a colossal collision in the early solar system, perhaps an impact so violent it tipped the planet over. But the evidence does not resolve neatly. The moons remain, the system persists, and the full story refuses to become simple. Uranus carries the look of an event we can sense but not fully reconstruct, like a scar whose original wound has been lost to time. There is something quietly human in that mystery. We know that lives, like planets, can be changed by singular blows. A tilt becomes a destiny. The world continues but under a different angle of light. And perhaps that is why Uranus stays with us. It reminds us that not every imbalance is temporary. Some become the new order, asking not how things were before, but what kinds of beauty and meaning can still emerge after everything has been turned sideways. How can the coldest reaches of sunlight give rise to some of the fastest winds in the solar system? Neptune should have been quiet, so far from the sun, receiving only a fraction of the light that warms the inner planets. It seemed destined to be a place of slow weather and subdued change. Distance suggested stillness. Weak sunlight suggested low energy. From Earth, that assumption felt reasonable, almost unavoidable. Then Voyager 2 arrived in 1989 and found a planet in motion. Neptune's atmosphere was not calm at all. It was dynamic, layered, and unexpectedly fierce. Great white clouds streaked across the blue, and dark storm systems marked the planet like shifting bruises in a restless sea. Among them was the Great Dark Spot, a vast storm large enough to rival Earth in scale. Around it moved winds so powerful they became some of the fastest ever measured on any planet, racing at speeds that challenged the old expectation that heat alone must govern activity. It was a revelation that did more than add one more spectacle to the catalog of space. It challenged a habit of thought. We often assume that less visible energy means less meaningful change. Neptune refused that logic. Somehow, despite its immense distance, it held onto internal heat and translated that hidden energy into motion on a planetary scale. What looked dim from afar was not dormant. It was alive in ways the eye alone could never have predicted. The discovery carried another quiet lesson too. Neptune's storms were not monuments. They shifted, appeared, vanished. Later observations would show that dark spots come and go, part of a weather system far more transient than the great long-lived storm of Jupiter. Even at the edge of the planetary family, the atmosphere was improvising. That impermanence matters. Neptune reminds us that mystery is not always found in what lasts forever. Sometimes it lives in what changes before we can fully understand it. A storm forms, moves, dissolves, and leaves behind only data, images, and questions. Perhaps that is why the planet feels so haunting. In the cold blue distance, it overturns a simple equation between warmth and vitality. It tells us that hidden reserves can animate even the most remote places. And it asks a question that reaches well beyond astronomy. How much motion might exist inside what we have too quickly called quiet? What if one of the strangest worlds in the outer solar system is a place that may not belong there at all? Triton does not orbit Neptune in the way a native moon should. It moves backward in a retrograde path, as though it entered the system under different terms and never fully forgot its even before Voyager 2 arrived in 1989. That backward motion hinted at an unsettled history. Triton looked less like something formed beside Neptune and more like an object captured from elsewhere, a wanderer held by gravity after a long and ancient encounter. Then the close-up images made the mystery deeper. Scientists had expected a frozen relic, a small body locked in silence by distance and age. Instead, Voyager found a surface that looked unexpectedly young, with broad, icy plains, strange ridges, and relatively few impact craters. Most surprising of all were the dark plumes rising from the surface, active geysers sending nitrogen gas and dust upward into the thin atmosphere before the wind carried them sideways across the moon. It was hard to reconcile with what Triton ought to have been. At such extreme cold, this world should have settled into geological stillness long ago. Internal heat should have faded. Motion should have slowed. Yet here was a moon still changing, still venting, still offering signs that deep processes had not fully ended. Even the frozen ground seemed to carry the memory of renewal, as if the landscape had been rewritten more recently than anyone expected. The leading explanation is that Triton began as a distant Kuiper Belt object, perhaps something like a dwarf planet. Before Neptune captured it billions of years ago, that event would have been violent, reshaping both moon and orbit. But capture explains only part of the story. It does not fully answer why activity persists, or why this far-off body remains more dynamic than a simple frozen model would allow. Triton feels like a reminder that belonging is not always obvious in the universe. Some worlds carry signs of displacement, of old upheavals preserved in motion and ice, and perhaps that is why it holds such emotional power. It suggests that even what was captured, diverted, or thrown off course can remain vivid and active long after the event itself has vanished from view. A moon from elsewhere still speaking through cold light and drifting plumes, asking how much of any history can ever truly be called settled. What if the edge of the solar system is not a graveyard of frozen ruins, but a place where change still refuses to die? For decades, Pluto lived in the human imagination as a distant afterthought. Small, dim, and impossibly remote, it seemed less like a world than a leftover, a relic pushed to the margins, too tiny to hold much of interest beyond its symbolism. By the time New Horizons arrived in 2015 after a journey of nearly 10 years, many expected confirmation of that old picture. An ancient sphere of ice, battered by impacts and largely untouched since the earliest days of the solar system. Instead, Pluto greeted us with a surface that looked startlingly alive. There was the great bright expanse later called Sputnik Planitia, a vast heart-shaped plain so smooth and nearly crater-free that it appeared geologically young. On a body this small, that should have been unlikely. Worlds of modest size are supposed to cool quickly, surrendering their internal energy early and spending the rest of cosmic time in silence. But Pluto had not settled into silence. Its plains seemed renewed. Its ices appeared to flow. Even its mountains, built from rigid water ice, rose like broken blocks above a softer landscape of frozen nitrogen. The deeper scientists looked, the stranger the story became. The surface showed signs of convection, as if the ice itself were slowly circulating, erasing scars and reshaping the terrain. There were hints of a thin atmosphere and growing evidence that, beneath the outer cold, Pluto may still shelter a buried ocean of liquid water. The farther from the sun we traveled, the more dangerous old assumptions became. That may be Pluto's quiet triumph. It reminds us that smallness is not the same as simplicity. We are often tempted to equate distance with emptiness, obscurity with insignificance. But this remote dwarf planet resists that instinct. It holds complexity where we expected closure, motion where we expected stillness. And perhaps that is why Pluto remains so moving. At the outer edge of the familiar solar system, it offers a final correction to our habits of judgment. A world can be far away, small in size, and still possess an inner life we never bothered to imagine until we finally came close enough to see it. What if the farther we travel, the less certain the map becomes? Beyond Neptune stretches the Kuiper Belt, a region once imagined as a sparse fringe of leftovers, but now understood as a vast archive of planetary beginnings. This is where sunlight grows thin and slow, where small worlds move in deep cold along paths that preserve memories from the earliest era of the solar system. For a long time, these bodies were little more than points of light, too distant for detail, too faint for intimacy. We knew they existed, but not what kind of story they were telling. Then the population began to grow. Astronomers found Pluto was not alone. There were others, Eris, Haumea, Makemake, and a widening family of icy bodies that did not fit comfortably into the older, simpler picture of 9 neatly ordered planets. Their discovery did more than add names to a chart. It forced a cultural reckoning about classification itself. What makes a planet a planet? Is it size, dominance, shape, history, or something more human? The need to place boundaries around what we can remember. The debate that followed was scientific but also emotional. Pluto's reclassification as a dwarf planet touched something deeper than terminology. It exposed how attached we become to the maps that organize our understanding. And yet the Kuiper Belt was not interested in preserving our convenience. It revealed a solar system, less like a tidy row of worlds and more like a layered ecosystem, full of overlap, gradation, and unfinished categories. In that sense, the Kuiper Belt changed more than astronomy. It changed the tone of our relationship with certainty. We were reminded that discovery does not always confirm the framework we begin with. Sometimes it dissolves it, replacing neat borders with richer ambiguity. And perhaps that is not a loss. Perhaps it is a sign of progress. The universe grows more truthful as it grows less simple, and the price of seeing clearly is often the surrender of names we thought were final. Out there in the cold beyond Neptune, countless small worlds continue their quiet motion, asking us whether wisdom lies not in drawing cleaner lines, but in learning how to live with a more generous kind of complexity. What do the most distant satellites really discover when they go searching for other worlds? In one sense, they collect measurements, images, spectra, fields, temperatures, particles, timings. They turn light into numbers and numbers into patterns. They tell us how a storm moves across Neptune, how ice shifts on Pluto, how a moon breathes through fractures or geysers into the dark. This is the language of science. Careful, disciplined, cumulative. But that is only part of what comes back. Again and again, the spacecraft sent farthest from Earth have done something more unsettling and more beautiful. They have revealed the limits of our assumptions. Each mission has shown that distance encourages simplification. From afar, worlds look finished. Up close, they become layered, unstable, surprising. The outer solar system is not a museum of frozen leftovers. It is a living archive of processes still unfolding, heat hidden beneath ice, weather rising in weak sunlight, delicate rings circling giants, and landscapes that remember collisions older than life on Earth. There is a quiet pattern in all this. The farther we travel, the less the universe behaves like a diagram. It behaves instead like history, shaped by contingency, accident, resilience, and time. A moon is captured and never becomes ordinary. A small planet remains active when it should have gone still. A haze-covered world turns out to have rivers, rain, and seas, though not the kind we know. Discovery does not remove mystery. It refines it. That may be why these missions matter so deeply beyond science. They remind us that knowledge is not the same as possession. To understand a world is not to reduce it, but to encounter more fully the reality of its difference. The satellites we send outward return with data, yes, but also with perspective. They teach us to be less certain, more attentive, more willing to let reality exceed the story we first told about it. And maybe that is the larger human achievement. Not that we reached so far, but that we allowed what we found to change us. In the cold outskirts of the solar system, our machines discovered distant worlds. Yet the deeper discovery was closer to home. Humility, sharpened by wonder, still may be the most reliable instrument we have. In the end, the story is not only about what lies far from Earth. It is about how distance changes the mind that tries to understand it. We began with the old habit of certainty. We looked outward and imagined the outer solar system as a fading extension of what we already knew. Bald Edigo, colder, dimmer, simpler. We expected silence. We expected completion. We expected that remoteness would mean emptiness, or at least a lesser form of reality. But every major encounter unsettled that expectation. The farther our instruments traveled, the more vivid the unknown became. World after world offered the same quiet correction. A belt once feared as impassable opened into vast emptiness. A giant planet hid rings too faint to see from the wrong angle. Moons once assumed dead revealed volcanoes, buried oceans, thick atmospheres, changing surfaces, and signs of ongoing energy where none was supposed to remain. Even the edge of the planetary map dissolved into a wider family of small worlds, asking us to exchange neat categories for truer complexity. That is the thread running through this journey. Not conquest, but revision. Not mastery, but perspective. The outer solar system has become a mirror in which human knowledge sees its own limits with unusual clarity. We discover, again and again, that reality is more inventive than the models we build from afar. And yet, this is not a reason for despair. It is a reason for wonder. Because to be corrected by the universe is also to be invited into a deeper relationship with it. Perhaps that is why these distant satellites matter so much. They carry our questions into darkness, but what they return with is more than information. They return with a different way of seeing, one marked by patience, humility, and a willingness to let the world be larger than our first description of it. In that sense, every mission outward becomes an inward act as well. A reminder that truth is rarely seized all at once. It is approached, refined, and sometimes received only when we are ready to release the comfort of simple answers. So the final lesson may be this. The universe does not grow smaller as we explain it. It grows more intimate, more textured, more alive. And somewhere in that widening understanding is a deeply human promise that as long as we remain curious enough to keep looking, the darkness ahead will never be empty. It will always contain another question, and with it, another chance to become a little wiser than we were before.